Okay, question 7D. Describe the main principles of the operation of a pump storage hydroelectric scheme. So if we're looking at a pump storage electric scheme, okay, we're looking at having two different reservoirs and we've got the flow of water coming down. So we've got two different reservoirs of two different heights and the water flows between them. Okay, so in this case we've got the water going from our high to low reservoir. Okay, and as it does, it passes through a turbine, and turbine's connected to a generator which generates electricity. During the low operating hours, so often at night time for example, any of the leftovers, any of the electricity that's being produced is also used and stored to then help pump this water back up to the high reservoir. Okay, so we've also need to break that down into those 3 points that we kind of describe for the 3 marks. So the first mark is that the water flows between reservoirs at different heights. Okay. Second one is the flow of the water is what drives the turbine. Okay, and then you can go on to say which is connected to the generator. Okay, generates electricity. And then for the third point, which is the system of it being a pump storage, is the idea of it pumping it back up. So if we look back on here, the idea of it going back up to our high reservoir. And again, you need to say during low or off-peak times. Low, off-peak times. The electricity produced is used to raise, again you can say pump but make it really clear that it is raising it, raise the water from the low to high reservoir. Okay, part 2. A hydroelectric scheme has an efficiency of 92%, so I'm looking at a fraction that's 0.92. Water stored in the dam falls through an average height of 57 metres. Determine the rate of flow of water in kilograms per second. Kilograms per second, that's mass over time. It's used to determine the rate of water in kilograms per second required to generate an electrical output power of 4.5 megawatts. Again, megawatts, so I'm going to convert that already. 4.5 times 10 to the 6 watts. So what I'm looking at here is I know my power is work done over time. Okay, so I can simply say power is energy over time. Oops, sorry, I dropped my pen. Power is the amount of work done per unit time. In this case, we're looking at it falling down, so we're going to be using our gravitational potential energy. So that's going to be mgh over time. But we know it's 92% efficient, so I'm going to put a factor of 92% in this. So again, multiplying that by 0.92. Okay. And then I'm just going to put in some values for the time being. So I'm going to put in my power is equal to 4.5 times 10 to the 6 equals m times 9.81 times 57 times 0.92 divided by our time. And again, I've now got that factor out, the rate of flow of water, so our mass divided by time here. So I'm just going to simply rearrange my equation. 6 divided by 9.81 times 57 times 0.92. That gives me a value of 8.7 times 10 to the 3 kilograms per second.